So in this last part of the video, I'm going to create a function that we'll be able to use root solver with, and it will give us the maximum temperature of this flame. So first we need to get at the total enthalpy of our stream going in and our stream going out. So we can use our enthalpy function at a certain temperature, and that will give us the enthalpies for, this one is methane, this one is ethane, this one is propane, and so on for all of our compounds. We also have an array for the moles. So to get the total enthalpy, we need to multiply the enthalpy of methane by the moles of methane, and the enthalpy of ethane by the moles of ethane, and all the way through, all the way for all of our compounds, and then add this up. A good way to do that is the dot product. So we can use np dot dot, and we want to do our enthalpy array times the stream in, and this gives us the total enthalpy for our stream going in at 1000 kelvins, or we could do for any temperature. So we can do a similar thing for the stream going out, and it'll calculate the enthalpy for our flame. So we do a dot product of the enthalpies for each compound and the moles of each compound, and this will give us the enthalpy of our flame. So the goal is to get these two enthalpies equal to each other. So again, I can do this by hand and kind of guess and check until these values match, or we can use root solver. So I'm going to move this into the same code block. So if we do the enthalpy of our flame minus the enthalpy of our stream going in, that will give us, that should equal 0 when the flame is at its maximum temperature. So now I will create a function that we can use for root solver, and I'll just call it equations. And we need to pass a vector of unknowns to it, since the root solver is meant for multiple equations of multiple unknowns. In this case, we just have one, which is temperature. So now we need to unpack it. So we'll just grab the first element of the vector that we're passing to our function, and then we just need to return this expression. And make sure it's in an array, because otherwise the root solver won't work with it. So now we can make sure that runs and put it into our root. So our function is the equation function we just wrote, and then I'll do a guess of 2000. And there we go. So that is the temperature of our flame. We can grab the x attribute and the first element so that we just get the number. So the maximum temperature for the flame using natural gas with 20% excess air is about 2063 kelvins.